Okay, so now let's do the hypothesis test for our running example, that being our regression between horsepower and miles per gallon. So let's just start with our hypotheses. And we just want to know whether it is significant or not. So we're going to do the two-sided test. So beta 1 is not 0, and beta 1 is 0. Step 2 is to select our alpha. So let's just go ahead and use alpha of 0.05. Step 3. So here we have 32 observations. Our sum of squares error. So I'm just copying this down from above. If you remember, we had 447.67 for error. Our variance of x, or our variance of horsepower, that would be 4,700. And our beta coefficient, or B1, is equal to negative 0.0682. Okay, so let's start with the standard error, so SB1. So in this case, we would have the sum of squared error divided by n minus 2 degrees of freedom, all divided by variance of x, and we're going to take the square root of all of that. So we already have all of these pieces. So SSE is 447.67 divided by 32 minus 2, so that would be 30, all divided by, put these in parentheses, the variance of x, which we said was 4,700. And then we need to take the square root of that value. So we put that into our calculator. I get a value of 0.0563. Okay, so now we can calculate our test statistic. So T-stat, we said, is equal to B1 over SB1. So that'd be negative 0.0682, right? That was our slope coefficient from up here. And we divide that by our standard error, which we just calculated to be 0.0563. And if you calculate that, you get a negative 1.21. So now let's establish our rejection region. So step 4. So our rejection region will be if T-stat is less than negative T, so n minus 2 degrees of freedom, n is 32, so 32 minus 2 is 30, so 30 degrees of freedom. This is two-sided, so we divide alpha in half, so 0.025. Or we have T-stat bigger than positive T, 30 degrees of freedom, alpha 0.025. So if you look that up in our tables, or what we'll do is just get these values from Excel. So if T-stat is less than negative 2.042, or if T-stat is bigger than positive 2.042. Our p-value, this is two-sided, so we multiply by 2, so it'll be 2 times the probability of T with 30 degrees of freedom, n minus 2 degrees of freedom, bigger than the absolute value of T-stat, so absolute value of negative 1.21. And if we calculate that, we get 0.235. So now we're ready to make our conclusion. So we could note that T-stat is not in the rejection region. How do we know? Well, our T-stat is what? Our T-stat is negative 1.21. So we just plug that in. Is negative 1.21 less than negative 2.042? No. Is negative 2.21 bigger than positive 2.042? No. Therefore, we would not reject the null hypothesis. So we fail to reject H naught. And then if we did the p-value, so we just found our p-value to be 0.235. Is that less than alpha? No, it is bigger than alpha of 0.05. And therefore, we would fail to reject H naught. So we did our conclusion. There is not enough evidence to conclude that horsepower and gas mileage have a linear relationship at the alpha equals 0.05 level of significance. Another way of saying it is that there's just not enough evidence to suggest that beta is different from 0. So we could say there's not enough evidence to conclude that beta 1 is different from 0. Okay, and then let's just quickly do a confidence interval. So let's do a 95% confidence interval. For beta 1. So we know that it is equal to B1 plus or minus Tn minus 2 degrees of freedom, so 30 alpha over 2.025 times SB1. So we already have all of these components. Our estimate for B1 was negative 0.0682. That is our slope coefficient. Plus or minus our critical value of T. Recall that was 2.042 times our standard error, which was 0.0563. And if you create this interval, that is going to range from negative 0.183 and 0.047. So we are 95% confident that the true beta 1 coefficient, or our slope coefficient, is between negative 0.18 and positive 0.04. So we could also just note 0 in interval, which would lead us to fail to reject H naught, because that means that we are 95% confident that 0 is the true beta coefficient. So because it's a plausible value, that would indicate that our beta 1 is not different from 0. So that concludes our running example. So in the next video, we will do one more example to finish out our notes.